Warning: the video you're about to watch contains mathematics at the level of college algebra and trigonometry. All material has an assumed prerequisite of both Algebra 1, which is elementary algebra, and Algebra 2, which is intermediate algebra. While some prerequisite topics are reviewed briefly, a more thorough review of these entrance topics can be found by searching the web.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcome.
Hello, my name is Roy Simpson, professor of mathematics at Cosumnes River College in Sacramento, California. This video is dedicated to college algebra students who just need a quick review of solving all different styles of equations. This one specifically is focused on solving radical equations. If you already know how to solve radical equations, then you can kind of skip this. It's just a review. But if you don't remember or you feel as though you need a review, here we go. So let's suppose you're handed a radical equation asked to solve. Here's kind of the tactic. Isolate a radical expression on one side of the equal sign. Your equation might have 1, 2, or 3 or more radical expressions within it. So you're going to have to do this several times. You isolate a radical. If the radical is a square root, then square both sides. If it's a third root, then raise both sides to the third power, so on and so forth. If it's an nth root, raise both sides to the nth power. If it was something like a 10th root, it would be terrible. You'd have to raise both sides to the 10th power, and that might be pretty bad. But after you do that, you want to quote unquote solve the remaining equation. Well, that just means start trying to solve what you have after you raise both sides to the second power or third power, whatever it is. But if you still have a radical in it, then you have to, again, isolate one of those radicals and again, square or cube both sides or whatever it is. And you repeat this process over and over again. In this case, I would not bother too much writing down the domain restrictions at the beginning because this can be very convoluted. Instead, I wait until the very end and check my answer. Let's see this in action. It's actually easier to see in action than for me to write out all the steps. This is a radical equation that I tend to give maybe an intermediate algebra student, somebody prior to college algebra, basically. Just pick one of those radicals. I'll pick this guy right here. In general, for me personally, I usually pick the radical that looks more complicated and I isolate that radical. There we have the radical isolated. Now I have to unlock this radicand by squaring both sides. Because it's a square root, I'll square both sides. That's the result of squaring both sides. I think the left-hand side's pretty obvious. You square that, the radical gets canceled with the squaring process. The right-hand side, a lot of people get this wrong because they think just squaring it makes this a 1 squared times or minus this squared. That's absolutely not true. This is when you square both sides, you're squaring 1 minus the square root of x plus 2. And so when you do that, that's a binomial. So it's 1 minus the square root of x plus 2 times 1 minus the square root of x plus 2. And when you do the mathematics, it turns into this business right here. Notice that my equation that results from this process still has a radical within it. So I will do the same thing that I did a moment ago. I'm going to isolate that radical. I'm going to get it by itself on one side. Since it's already on the right-hand side, I'll leave it on the right-hand side. I'll move everything else to the left-hand side. So I subtracted x from both sides and I subtracted 3 from both sides. And now you can see I've isolated this radical. It's probably a good idea if you can, and it doesn't create fractions, to divide both sides by the coefficient of the radical as well. Dividing both sides by a -2 will not create fractions, so I'm pretty okay with doing that. And you arrive at -x minus 2 is equal to the square root of x plus 2. Now I will have some students that will stop here and say no solution because square roots can't equal negative numbers. However, you do not know if that left-hand side is a negative number because that left-hand side has an unknown. What if x was a -1,000? Then you'd have -1,000 or a +1,000 minus 2. And so that left-hand side would become positive. So you don't know if that left-hand side is positive or negative. Just because there are minus signs over there does not mean it's negative. Anyhow, let's square both sides. Again, I just quickly squared it out. This is just something you should know from stuff that you've worked through for years. You're squaring both sides, and negative x times negative x is x squared. Negative 2 times negative x is a positive 2x. Negative 2 times a negative x is another positive 2x, so that's positive 4x. And then finally, negative 2 times negative 2 is positive 4. So that's just the binomial distribution right there. You should be okay with that. Now I'll just collect everything on the left-hand side and see if this factors. And this totally factors. This is going to factor to an x plus 2, x plus 1. And so my candidate solutions, I say candidate because we have to check them, are x equals negative 2 and x equals negative 1. Now, where do you check those? In radical equations, you check all the way back at the beginning. So all the way up here is where you're going to plug in negative 2 and negative 1. I'll do my check in blue. X equaling negative 2 will imply that we have the square root of 3 times the negative 2 plus 7, or in other words, square root of 1, plus the square root of negative 2 plus 2, which is square root of 0, and then minus 1. And the question is that equal to 0? And the answer to that is totally. That's 1 minus 1 totally is 0. Check, that is true. So I know that this is a solution. Now I'm going to try the second one, x equals a negative 1. Plug in a negative 1 into this. Negative 3 plus 7 is 4, so that'd be the square root of 4. Plus, square root of negative 1 plus 2 is the square root of 1. Minus 1, and again, is that equal to 0? Well, that'd be 2 plus 1 minus 1. Nope, that's not 0. That's going to be 2. So this is not a solution. This guy right here is an extraneous solution. So our only solution to this equation is going to be the x equaling negative 2, and we get to throw out the x equals negative 1. That last example was a good illustration of the fact that you do have to check your answers for radical equations. Generally, it's best to check them at the very end. In this equation, we see nested radicals, which just means it's just going to get a little more complicated as we go through. Not a big deal. It still operates just like any other radical equation. You'll isolate one of the radicals, which luckily it's already isolated the most complicated radical, and then you're going to square both sides. When you square both sides, you get the following. Now I'm going to zoom in a little bit just because my pen gets shaky when I'm zoomed out so much. Remember, you're squaring this entire left hand or right hand side. So that'd be the square root of t plus 3 being squared. When you do that, that's the same thing as square root of t plus 3 times the square root of t plus 3. And that should not be anything crazy. It's just t, what is that, plus 6t, 6 root t that is, and then plus 9. Notice I have an equation that still has radicals within it. So I will isolate the radicals. And in this case, something very fancy happens. I'm going to go ahead and subtract 6 root t from both sides, but when you do that, you'll see they cancel beautifully, and you're left with, in fact, I'll subtract 9 from both sides as well. You're left with 10 is equal to t. That's a very fast equation to solve. Now we just have to check to see if that's actually correct. Now checking this is going to be a little bit of a mess because when you plug in 10 for t, it's not clean. It's 6 root 10 plus 19, and we're asking, is that the same as root 10 plus 3? Again, we'll have to do what we just did, which is square both sides. You get that 6 root 10 plus 19 is equal to 10 plus 6 root 10 plus 9, and that is actually true. 19 is totally equal to 19 because the 6 root 10s will cancel. So that is true. It does work out. So we do have this clean solution here. Checking it was not the easiest just because it doesn't, the square root of 10 is not a nice number to compute. But that's okay. Just because it's not nice doesn't mean that you can't check it. It's pretty easy to check, actually. So that's all we need to do when we're solving radical equations is isolate a radical, square both sides, or cube both sides, which is not going to happen, honestly, that often, but squaring both sides does. And then if you still have radicals left over, rinse and repeat. Just continually do that same process over and over again until all radicals are gone. Check your answers in the end. All right, that does it for this video. I hope that was helpful. I will see you, hopefully, in the next video.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes obstacles getting in our way. Cause affects more than we can sometimes see. Things for what they are and work together until you feel at peace. Says, listen close, don't talk too much that isn't cold. Sure, you may really hurt inside. It doesn't justify you to speak too loud and cry.